Hi guys, Dr. B here. So we're going to look at electron orbitals and configuration. So electron orbitals. So it's the official definition. It's a region of space around a nucleus of an atom, not atomic, where an electron is most likely to be found. Electron orbitals are what allow atoms to make bonds, which we'll talk about later on. Just FYI, electrons can travel at 2,200 kilometers per second, so it's pretty fast. So when you look at this, this kind of should look familiar. It should look like Bohr's model with the nucleus in the middle and the electrons in orbits. So there are different suborbitals, S, P, D, F, and just the reason why I'm showing this is kind of like what you saw in the video in class when they talk about quantum mechanics and electron cloud theory and all that. And so these suborbitals, they're regions of space in where an electron, is most likely to be found. And this is just the order that they come in. And you will hopefully recognize that when you start looking at these configurations, it's actually based on the periodic table. Well, this is when you look at it, the periodic table and the orbitals somehow fit together, so to speak. So the order is S, P, D, F. So the number of possible electrons in each orbital. In S, it's 2, P is 16, D is 10, and F is 14. And I will tell you that these will correspond with how the periodic table is laid out. So there are a total of 3 rules or principles you need to be aware of. Pay attention, fill in your graphic organizer, etc. And there are a couple of questions I'm going to have throughout the lecture that may not appear on your notes, but I suggest you still pay attention and follow along because it will hopefully help understand the concept. So this is from an assignment that I had last year, but I want you to kind of see it. So if you'll notice that this is the same house, but at different times they have different amount of tenants in them. So just kind of looking at it, the manager's code tells you how many occupants and what floor they are, what room they're in, etc. So using this as an example, as something to kind of refer to, based on where a single electron is placed, the lowest potential energy electron in an atom is found in the blank cell level. So this means that when you look at these different images, which sublevel or which floor is going to have the lowest possible energy? And I'll tell you that it is the 1s level. This is where the lowest possible energy is. Hopefully this will start kind of clicking as we go through the lecture. Electrons will only occupy a p orbital only after one of these answers. So what we mean by p orbital is actually in these pink rooms right here. Notice that electrons will only occupy a p orbital after the what? So notice how you don't start jumping to the p orbitals here. Even if we started having these 2 people down here, these here, etc. Notice that we don't just start putting people in these different beds. We actually have to wait until the previous s orbital is completely full before we start putting people in the p orbitals or in the pink rooms. So what principle is this related to? It's called the Aufbau Principle, and the term Aufbau means filling up. So electrons in the ground state, or the lowest energy, will fill from the least to the most energy, from the bottom to the top. The lowest energy would be the 1s sublevel or 1s orbital level. Electrons will only pair up in an orbital only when. So when do these suckers start pairing up? They only start pairing up when there is some. Notice how these don't pair up right here. It's only happening after all orbitals in the same sublevel have 1 electron. So this is related to something called Hund's rule. Electrons will only pair up when all of the orbitals at a given energy already have one electron. And all lone electrons within an orbital have the same spin. So this will be indicated by this. So it's kind of an arrow, but not really. So these will indicate the spin of an electron. You'll see an example later on. So here's a freebie, no questions with it. Pauli exclusion principle. Electrons can only share an orbital if they have an opposite spin. So what I drew earlier, this is considered an opposite spin. Alright guys, so I decided just right now that I'm going to end the lecture here. So this is the end for now. When y'all come back to class next week, we will talk about energy level diagrams. And then that will be our topic for the next few days. Alrighty, take care guys, be safe.